Okay, welcome back. So now we're up to going back to the question, the question I asked before at the very beginning of this section of this chapter, of this topic of parametric equations or calculation of parametric curves, is the baseball, right? Figuring out how far a baseball travels over a certain period of time. So let's say that we have that example. And so the setup is we're going to assume that the ball travels, or the path the ball travels, the distance the ball travels. Well, when the path is parabolic, unless it's a curved ball, but we're not going to consider a curved ball. So the pitcher throws the ball. When the ball is released from when the ball is released from the pitcher's hand, we're going to consider that the origin. And so the ball is traveling left to right on the positive x and the positive y, okay, from left to right. And what else? So I just drew a little sketch of like the path that the ball might take once it leaves the pitcher's hand. And also we've got these two parametric equations that represents the path the position of the ball as a function of time t. Okay, now in this case, t represents time. Okay, so we want to find the distance the ball travels. Now, when I say distance, I'm not talking about the horizontal distance. I'm talking about the arc length. Okay, so in this case, distance, which is the arc length here, is going to be a function of time. Okay, so we're going to have to use a different variable to represent the parameterization here. Okay, so we're going to use a dummy variable. We're going to use an independent variable, and we're going to replace it with t, because what we need to do is we need to rewrite this function, right? So we're going to use this function from t1 to t2, right? And this is going to be the square root of x prime of t squared plus y prime of t quantity squared dt. Now here's the problem. I've got a function in time, but then I've got these parameters of t, and they don't all mean time. Okay? So I've got to use a dummy variable. So what I'm going to do is I'm going to rewrite this in the scenario that time, so we're going from 0 to t, right? So the distance as a function of time is going to be the integral from 0 to t, and then what I'm going to do is I'm going to just rewrite these with dummy variables. Okay, so I'm going to just use v. Okay, oops. So again, v is just a dummy variable. So then this is going to be v, right? Now the dummy variable is going to go away once we integrate. Okay, so this is going to represent the distance function. This integral now, this arc length, right, is going to be represented by this function, which is going to be represented by this integral by using the arc length function, or the arc length formula that we derived earlier. Okay, so now we just have to take the derivative. Okay, so just want to make sure everything's correct. Okay, so now the derivative, so So let's put this in here now. So this is going to be the integral from 0 to t, right? T here represents time. Okay. And now we're going to integrate this from 0 to t. And it's going to be the square root. Now, the derivative of this is 140. So this is going to be 140 quantity squared plus, and the derivative of y of v is going to be what? It's going to be negative 32 v plus 2 quantity squared dt. Okay, now the formula that we're going to use to integrate this. Okay, so to integrate this, we're going to use the following formula. Okay, and again, you can get this from the integral tables, or you may know it, but this is the one we're going to use, and it's the integral of a squared, the square root of a squared plus u squared. So note the integral of the square root of a squared plus u squared du, okay, is equal to u over 2 times the square root of a squared plus u squared plus a squared over 2 times the natural log of the absolute value of, oops, hold on a second. Forgetting a u in there. U. Okay, so this is the integral. This is the expression that we're going to use. Okay, and again, you can get this from an integral table, or you could use the techniques that we've been using to integrate this. But again, in this case, I would definitely just use the integral table, because this is a common form. So, and this does have the form. So 140 would be A, right? So in this case here, A is equal to 140. Your U is equal to this, so U equals negative 32 V plus 2, okay? Which also means that then du equals negative 32 dV right? Okay, oh, wait a minute. So you're used to dt, sorry about that. dv, this should all be v's. Yeah, this should all be v's. The only t should be this one. So all the rest of this is v's. Okay, so now, so we've got this set up. Okay, so that's the expression we're going to use. And so now if we solve this, then we can rewrite this using this expression. Okay, so I'm going to go to the top here, because I don't want to erase this. I can erase this. Okay, so now, using this here, we're going to rewrite this, okay, And of course, this would mean that, by the way, we could put negative 1/32 du is equal to dv. Okay, so now we're going to just substitute in this into this right here. Okay, so that means, what are we going to get? We're going to get the integral. Oh, hold on a second. Yeah, we're going to get u over 2 right? So this is going to equal, so we're going to substitute in here for this. So this is going to give us negative 1/32 times the integral of so a squared plus u squared du. And so now all we're going to do, and this is from 0 to t. Well, we'll put it back in there in a minute. So this is just going to be equal to, again, a is 140, u is equal to this, and then negative 1/32 du is equal to dv, okay? So now all I'm going to do is I'm going to plug in this value. So all I'm going to do is u is what? This. So I'm going to put in negative 32 plus 2 over 2. Okay. And then I get this, which is square root of 140 squared plus negative 32v plus 2 squared plus, and then a squared. Right, so this is going to be 140 squared over 2. Oh, you know what? I'm going to do it down here. So this is going to give us plus 140 squared over 2 times the natural log, right? And then I got u minus, well, what's u? U again is this, so I'm going to get negative 32v plus 2 plus the square root of 140 squared plus negative 32v plus 2 quantity squared. Right, and that absolute value there, right? Okay, now, this, well, here, if we do Okay, now, but this is a definite integral. So this is going to be evaluated from 0 to t. Now, okay, so now here, because we did a u substitution here, so we want to make sure that we do the correct limits of integration. So in this case here, the limits of integration are going to be from what? When v is 0, we get 2. Okay? No, actually, I'm sorry. No, we can leave that as 0. Never mind. Can't do it. So 0. Yeah, because we're back to v. Yeah, I put everything. I'm sorry. We put everything back to v. So I can go from 0 to here. So what happens at t? Okay, well, let's do that. So now we're here, and we go from, so now we're going to evaluate at t, so the only difference, I'm going to give myself some more room. So if I evaluate at t, this is going to give me what? It's going to give me 140 squared over, I'm sorry, wrong, starting in the wrong place. It's going to give me, hold on a second. This should be a v. So I'm going to get, at t, so all these v's are going to turn to t, so that's going to give me negative 32t plus 2 over 2 times the square root of 140 squared plus negative 32t plus 2 quantities squared, okay, plus 140 quantities squared over 2 times the natural log of the absolute value of negative 32t plus 2 plus the square root of 140 squared plus negative 32t plus 2 quantity squared. Okay, now, what do we have now? Well, now we're going to evaluate it 0. So it's going to be minus. Now we're going to evaluate this thing at 0. Well, at 0, this just becomes 2 over 2. So it becomes negative, right? Negative square root of 140 squared. This just becomes 2 squared. So this just becomes 2. Oh, hold on a second. Not negative. This becomes positive. Yeah, sorry, positive 1. So this becomes positive, and this becomes this plus, this just becomes 2 squared plus the natural log. Oh, sorry. Plus 140 squared over 2 times the natural log of the absolute value. And this becomes 0, so we get 2 plus the square root of 140 quantity squared plus 2 squared, like so. Okay, now the one thing I'm missing is this 1/32 here. So this is going to be negative 1/32. And then if I distribute this, it's going to be, this is going to be a plus 1/32. Okay. So now that's correct. Okay. Now I know this looks like a monster. And for all intents and purposes, it is. Okay. Okay, so now let's simplify this a little bit. Okay, now again, I'm not going to do all the work, but a lot of this stuff we can simplify. Again, verify that this is correct. So what I get is t over 2 minus 1/32 times the square root so this is going to be s of t, right? And I get 1,024 t squared minus 128 t plus 19,604 minus 1225 divided by 4 times the natural log of the absolute value of negative 32 t plus 2 plus the square root of 140 squared plus Oops, hold on. Plus the same thing here. So again, this also goes in there. So we're going to have an absolute value here. And then the last term plus the square root of 19604 divided by 32 plus 1225 divided by 4 times the natural log of, well, we don't need the absolute value since it's a constant. So it would be the natural log of 2 plus the square root of 19604. Okay, and that represents the distance traveled by the ball as a function of time. Okay, now, the reason why I'm showing you this is it's not bad. I mean, it takes me a while, right, because I'm writing it out, I'm explaining things, but it's a little tedious, but it's not bad. None of the integration was horrible, other than all we had to do is remember we had to use the form. Again, you can look that up in the appendix of your calculus book, or you can look it up on an integral table online. So there's lots of places you can go for that. But the algebra and stuff isn't horrible, okay? There's nothing that jumps out at me that would be terribly difficult. So the point is you can figure out something like this using what we've used easily with parametric equations, okay? So, now the other thing, what about the velocity? Now the velocity, you might think, oh, this is going to be daunting. It's not actually that bad, okay? So if you want to calculate the speed, then you have to take the derivative of this function, right? So we have to take the derivative of this function with respect to t. Now, you might think, oh boy, that's going to be difficult. But it's really not, okay? Because if we remember the fundamental theorem of calculus, right? So let's start over here, because let's just okay, so what is S of t, right? So we found that the formula, right? So S of t is equal to the integral from 0 to t, and this is what we started with, right? Of 140 squared plus negative 32, not 2. So negative 32 v plus 2 quantity squared dv. Okay, so that was the function we started with, right? So now, keep in mind, what does the fundamental theorem of calculus say? Okay, the fundamental theorem of calculus says that if we this, right? The fundamental theorem of calculus. Oops. Okay. Says that if we want to take the derivative with respect to x, I'm just going to use x, of an integral, right? From a to t. Let's say. or a to x. Okay? So if we take the derivative of function, so here's our function, right? And we have the integral of f of u du, right? So the fundamental theorem says that, again, this is assuming that the antiderivative exists, right? Okay? The fundamental theorem says that this is just going to equal the value of the function, the function evaluated at x. Okay, so remember that. The fundamental theorem of calculus says that, hey, if I have an integral from a to x, right, of a function, and I want to take the derivative of this integral with respect to x, then it's nothing more than just the function evaluated at x. Okay? So it's just f of x. So if I apply that to this, and I want to find the velocity function, right? So I want to find v of x, or v of t rather. So I want to find v of t. Well, that means I'm going to take the derivative of s, right? So I'm going to take the derivative of s with respect to t, right? So I'm taking that. But that's the same as taking the derivative with respect to t, right? Of the integral from 0 to t of 140 squared plus the quantity negative 32v plus 2 quantity squared dv. Okay, so now what happens? Well, if we use the fundamental theorem of calculus, then all this is that this will just equal this function evaluated at t. So v of t then becomes what? The square root of 140 squared plus negative 32t plus 2 quantity squared. Okay, and so what do we get? Well, if we simplify this, what do we get? We get the square root of 140 squared, which is, this is going to give us, let's see, 19604, okay? So then we split the, if we expand this out, then this is going to give us 1024 t squared minus 128 t plus 19,604, okay? And so we could factor out a 4, so we could factor out a 4 of all these terms, and so if we factor out a 4, then the square root of 4 is 2, so we get 2 times the square root, and so our final answer is going to be 256 t squared minus 32t plus 4,901. And so that becomes the velocity function, okay, with respect to time. And that's it. Have a great day.